we want to know, what does the derivative tell us about the function? What are some things that you can already tell me? If the derivative is positive, what does that tell you was happening on the original function? It was going up. It was increasing, because remember, a derivative is the slope of a tangent line. So if your tangent lines have a positive slope, your graph was rising. So when your derivative was negative, your graph was decreasing. Okay, then when your derivative is 0, what does that tell us? Okay, what have we just been finding on, not this past section, but you did it on that quiz? When you were finding your critical points, you were finding maximums and minimums, right? And so anywhere our derivative is 0, that's where we can get a high or low point on our graph. So we already know quite a bit about this. Let's kind of jot it down then. So the increasing and decreasing test, if the derivative is positive, then you can tell me f is increasing. If the derivative is negative, then the original function was decreasing. So let's do that, no problem. I want to know where this function is increasing or decreasing. So first thing we're going to do is what? What do you think we should do first? Find the derivative. If it's based off what the derivative is doing, we need a derivative. So that would be 2x minus 4. Then what do you think we need to do? Set it equal to 0. Is this going to have any points where the derivative is undefined? No. If we're talking about polynomials, our derivative is never undefined. If we set that equal to 0, we get x equals 2. What do we call that number when x is 2? Critical point. Okay. So we know that that is going to be a maximum or minimum. So that's a point where our graph switches from increasing to decreasing or vice versa. To figure it out, let's make just a little sign. Okay, so 2 is the point where it changes. Then we need to know what it is doing on either side of 2. So let's just pick some test points, numbers we can just plug in easily. So something smaller than 2, maybe a 0 or 1, something bigger than 2, maybe I just want to put in 3. Okay, we know the function is increasing if the derivative is positive. So we are plugging these into the derivative. So if you put a 0 into your derivative, we get out negative 4, so it was a negative. If we put in a 3, we get out positive. So my function is decreasing until we get to 2, because the derivative is negative. So that would be negative infinity to 2. Then after 2, my derivative is always going to be positive, so it's going to be increasing from positive 2 to infinity. So to figure this out, we're kind of just connecting all the dots, all the things that we already know. We do our derivative, we find our critical points, and then we're making a sign line. Okay, and this number line is based off the derivative. We are looking at when the derivative is positive or negative. Is that okay with everyone? Let's try another one. So first step is derivative. So what's my derivative? Okay. We need to know when this is 0. What can I do to that? 12x. And then x squared minus x minus 2 would factor into x minus 2x plus 1. So what are the critical points? And? Okay. So these are the places where my graph might switch between increasing and decreasing. These are the only places where the derivative is 0. So when I make my sideline, make sure you go left to right, small to large. We need a test point for each of these intervals. So something smaller than -1. Something in between -1 and 0. Something in between 0 and 2. And something bigger than 2. And where do I plug these in? The derivative. Might even be easiest to plug it into your factored one, because we don't even really care about the number, do we? We just care if it's positive or negative. So let's just think about this. If you take a -2 times 12, that would be a negative. -2 minus 2 is negative. -2 plus 1 is negative. If you multiply 3 negatives, what do you get? A negative. If I put in a -1/2, -1/2 times 12 is negative. -1/2 minus 2 is negative. -1/2 plus 1 is positive. So this section turns out to be, if we put in a 1, 12 times 1, positive. 1 minus 2, negative. 1 plus 1 is positive. So that section is, I put in a 3. 12 times 3 is positive. 3 minus 2 is positive. 3 plus 1 is positive. So that's positive. Does everyone understand where I'm getting my positives and negatives? Okay. Just a kind of a word of warning. You notice those signs alternate? Most of the time they will, but not always. So you can't just find the first one and assume all the others will alternate. But if you get the same sign twice in a row, like negative, negative, or positive, double check yourself. It can happen, but it usually is only when like you have a square on one of these parentheses or something like that. Mm-hmm.
So what numbers are you plugging in to get the negatives and positives?
These test points that I picked.
Okay.
So we know like the actual points I plotted on my number line, those are the zeros. Those are the places where we will switch between increasing and decreasing.
Okay.
So then we just pick a point in each interval to plug
And
in.
you're plugging it into each x.
Yeah, and the derivative. So where is my graph increasing? Where is this graph decreasing? All right. So we know this graph started out decreasing. So my polynomial, it was going down, right? And then it switched to increasing. If you're going down and then you start going up, what is this point called? A minimum. Okay, then we were going up and we switched to going down. So what's this? A maximum. So we see these critical points are the maximums and minimums. So that's what's called the first derivative test. If our derivative changes from positive to negative, that means you're increasing, then you start decreasing, you have a local max. If our graph switches from negative to positive, you get a local min. If it does not change, then it's neither one. So if I have positive, positive, that means it was increasing, it's still increasing. Or if it's decreasing and it's still decreasing. If there's no change, then we don't have a maximum or minimum at that critical point. Remember, critical points are places where we could have a maximum or minimum, not guaranteed that we do. All right. Any questions so far? So let's find the local maxes and mins. This was the problem in example 2. Okay, so we don't have to redo everything. Remember, we did our sign line there in example 2, and we were already kind of starting to talk about it. This was decreasing, and then it switched to increasing. So what's happened at 1, or at -1? Local min. And we're going to give ordered pairs, or you can write it in punch notation. How would I get the y value? Right. We want to put it into the original to get the y value on the original graph. So that would give me 3 plus 4 is 7 minus 12 plus 5, which is 0. If you prefer, you can write it as a point. I don't care. So then if we look back on number 2, then at 0 we went from increasing to decreasing. So at 0 we have a local max. If you put 0 into the original, we get 0 minus 0 minus 0 plus 5, which is 5. Or you can write it as a point, 0, 5. Then at 2, we went from decreasing to increasing, so 2 is a local min. So if you put 2 in, -27. So you have to determine if it's a max or min, and then to give me the actual order pair, we put it back into the original. Why don't you guys try example 4? So find all the critical points and decide if they are maximums or mins. So you did your critical points. So your derivative equal to 0. You can pull out a 6. When you're doing your critical points, does 6 ever equal 0? No, so it doesn't change anything. So the only critical points are at +3 and -2. Then our test points, smaller than -2, would be -3, in between the two of them, and bigger than 3. Did you guys include 0 as a critical point? If there had been an x with it, then it would have been 1. So now we plug these in where? derivative, because we want to know if the derivative is positive or negative. So these points are going in here. If I put in -3, I have -3 minus 3 is negative, -3 plus 2 is negative, so that section turns out positive. If you put in a 0, you have 6 times 0 minus 3 is negative, 0 plus 2 is positive, so we get negative. If we put in a 4, 6 times 4 minus 3, positive, 4 plus 2 is positive, so we get positive. Okay, I didn't ask you to state it, but where is this increasing? Negative infinity to 2, union 3 to positive infinity. It is decreasing from -2 to 3. Okay, I asked for max and min. So if we look at -2, my graph was increasing and it switched to decreasing. So that means we have a local max. Okay, x is -2. How do you get your y? When you put that in, what do you guys get? 51, thank you. Okay, then at 3, my graph was decreasing and it switched to increasing. So what happened at 3? It's a minimum. If you put 3 into the original, what do you get at? Thank you. Alright, so we are finding local maxes and mins here. I think I'm going to do one last problem. This one is not a polynomial, but we can still apply the same principles to it. If we look at this one, so classify the critical points. We're finding maxes and mins. Our derivative if we put that in, so derivative of 4 is 0 plus 1/3 x to the -2/3. Okay, if you want to rewrite that, a negative power puts it on the bottom. A 2/3, that means it's the cube root of x squared. Does this ever equal 0? No. Is it ever undefined? Yes. Where? If you put in 0, you get a 0 on the denominator. So that is my only critical point. Remember, critical points are where the derivative is 0 or undefined. Polynomials, it's never undefined, so we're just looking at the 0. But when we have fractions, we have to look at the denominator as well. So that's the only point I have to test. If I put in something bigger and something smaller. So if we put in -1, this is 4 plus the cube root of -1. Okay, what's the cube root of -1? Oh, sorry, I'm putting these into the derivative, not the original. If I put it in here, so it's 1/3 cube root. But when you square -1, it becomes positive. So what am I getting out? A positive. If I put in a 1, I get 1/3 times 1, so it is positive. So my graph was increasing, and then after 0, it's still increasing. So what does that tell me? Do we have any maxes or mins? No. So it is possible to get the same sign twice in a row. Alright, I am stopping here today. I want you to practice the 2 things we've done. So I have a handout. The first 5 questions are maxes and mins. The second 5 are increasing, decreasing. They are all polynomials. So nice, easy, pretty.